In this video, we are demonstrating the Open Research Knowledge Graph, or ORKG, a system to curate, explore, and contribute to scholarly communication. The ORKG aims to change the way that we represent scholarly information. Looking into this UI, this is the main interface of the system. It can be accessed via the link here. The system is still in its alpha stages, so some data may be changed or deleted without notice. The main sections of the user interface are the research fields, where you can see the scholarly contributions organized in a hierarchical structure under their respective research field. For example, if we need to find databases, we need to go under mathematics and then computer sciences. Here we find databases and information systems. Moreover, another view of the system would be to look into the recently added papers. Here we see the most recent papers added. Since the system is going to be used by technical and non-technical personnel, the terminology used is generic, to make it easy as possible for everyone to understand. Moreover, no mention of the terms graph or knowledge base is being mentioned. Not to confuse users with technical details, the user interface handles everything for the user and collect the information in the representation that will be part of the graph later on. Now let's dive into how the system works. So we select a paper, which is this paper that we are going to take as an example, and we're going to enter it into the system. So starting with the wizard, so we see here there's a wizard called Add Paper. It takes us step by step to add our information into the system. The first step would be the general, so we need to enter a general paper information. So we see there's an option to add it via paper DOI. A DOI is a digital object identifier. So to identify the paper, so we can take it from here. So in this example, this is the DOI that we're working with. So we put it here. We can fetch the metadata such title and author and publication date from external services like Crossref. We look up the results, we get the title, the authors, and the publication date. Moreover, we can edit this manually. So we see here, after we click manually, we can actually have access and edit all the information. So for example, we can change the date from December to November. This would be also helpful in the cases that a publication or whatever scholarly information added to the system doesn't really have a DOI yet or at all. It can be directly entered manually. Next step would be to select the field of study, which in our case is information systems. So we need to go under physics, physical sciences and mathematics, then computer sciences, and then we will be able to find, for example, databases or information systems. Then we move on to the next step. Having this selection is helpful because the wizard, once it has more data or more contribution into the system, it will be able to populate a certain set of commonly used predicates in this domain, such as, for example, implementation or evaluation, in this case of, for example, computer sciences. So it will be helpful to the user to have a subset or a set of some predicates to work with. So here we see that the title, or basically what should we do, is to specify research contribution. A contribution is the core concept of the system. Everything revolves around a contribution. So a contribution has a research problem. So we could have more than one research problem. So in our case, the first contribution would be, for example, relation linking. Also in the future, here there will be auto-completion, so you will be able to link to existing relations in the system. Moreover, for the contribution data, now we see that there's basically no values here, so we start by adding a property. The first property we're going to work with is, for example, implementation, because the system has an implementation. So we select this from the list. We see that the autocomplete helps us with that. Now for the implementation, we need to add a value. Now we see that we can select either an object or a literal. A literal basically is a value, like a number or a plain text, and an object is an object by itself that can be referred to and furthermore explained. So in our case, we will refer to an object, which is, let's call this GitHub, and we see that the autocomplete helps us. So we will call this GitHub implementation. Now we can actually navigate into the GitHub implementation and add more properties there. So for example, we can say that it uses a programming language. We see that it also autocompletes for this for us. We can choose it. Now in the programming language, we can actually add what is the programming language used. So in this case, it's Python. And now also Python is used here. The nice thing that we can actually use it. Here it's indicated that actually this is shared among multiple contributions. So this means that Python is a shared concept among multiple resources or contributions in the systems. That's the benefit of reusing concepts. Moreover, we could say that this is also, for example, implemented in, let's say, Kotlin. Also, it's there in the system. Also, for example, we can add another property, which is URL. Also, it's there in the system. Now we can add the URL of this implementation. The URL itself will not be an object, it will be a literal because it will be just text. So we go here, take the implementation of this paper and add it here. So now we have it here already. Going back, so we can also say that this contribution presents some sort of system, which in this case it presents a system called SIBKB. So we will say presents. We see that presents, it's not really here, so we need to create this new property. The system allows us to do this, but it will note for the user that often there are existing properties that cover whatever you're trying to describe. But in some cases that if there isn't, you can create a new one. Here you can create it, and now it's in the system. So you or other people can actually reuse the same property without the need to enter it again. So here we will say, for example, it presents a system called SIBKB. It's an object by itself, so actually other people can contribute to the SIBKB and describe it more. Furthermore, for example, we can describe another contribution. This contribution would be question answering. It's a different contribution, so the same paper has two contributions. Each one is addressing different problem. Also, for example, for this contribution, we can say that it uses a pattern file or a pattern library called Patty. Also, Patty is an object, so it can be described furthermore. So now, if we are satisfied with how we described our contributions, we can move on to the next step, and basically the paper has been added to the system. Now we can actually see it, we can navigate it. So we can, for example, go to the GitHub implementation. We see that there are two values for the programming languages, which are Kotlin and Python. Kotlin itself is a further resource which can have multiple properties. In this case, it doesn't. We see here also in the breadcrumbs, you can know where exactly you are in the hierarchy that you navigated. So you can go back, for example, to the GitHub implementation, also look up the URL, and it says here this is the URL of the implementation. Also, the second contribution has a different problem, but the same idea. Now, if we go back to the homepage, we can actually see our paper in the recently added section. Also, if we navigate through the mathematics, computer sciences, and then information system, we can actually see it there also and investigate it furthermore. So this will allow us to contribute and add more information to it, or allow other users to do the same. Other features with the system would be, for example, the ability to search. The search is still now a bit generic. Overview, you can basically search for everything. So we can say why reinvent, which is a part of a name of the resource. So we can see here no predicate found for this search query, but there is a resource which is the paper which is called Why Reinvent the Wheel. Next steps of the systems would be the stuff that actually the system in the system that we are working on. So for example, we see here there are something called similar contributions. So the idea would be to get the most similar contributions to the system, which will help in literature review and other aspects to get, for example, something that addressing the same problem or has the similar parameters, predicates, implementations, approaches. It would be helpful to get what is similar in the literature. Also, another feature would be to show a comparison. So we would have something like this where we could actually see what is how a certain contribution would compare to other contributions if they have similar properties. So we could have them in this tabular format where you can actually look at them and then at a glance get an overview of the state of the art or whatever contributions or papers you're actually looking into. You can try the framework again from the link that is shown here again. The system is open source, so please feel free to contribute to the system, raise any issues. So you can actually go to gitlab.com. The organization is called TIB Hanover. You can go there. There's an entire package of projects called ORKG, which is the general agenda of the project, the Open Research Knowledge Graph. Here we see projects in there which are the back end, the front end, and the newly developed the similarity and the comparison framework. All of this can be downloaded and used. Everything has some documentation, how to run it and install it on your local system. You can raise any issues you want. Please feel free to add issues or suggest new features. Also, the project has a page you can also visit and add any opinions you have there.